Today's video is on understanding accuracy and precision. In other words, measuring with purpose and evaluating data quality. Why accuracy and precision matter? Well, in this video, you will learn the definitions of accuracy and precision in measurement. You'll also explore the difference between being correct and being consistent. You'll practice identifying these concepts in real world contexts and visual examples. And you'll understand the impact of tools, units, and human error on measurement quality. So, this is going to help you develop more thoughtful and reliable measuring practices in both math and in science. So, let's start out with something fun. Which one doesn't belong? Which one of these pictures? You might want to pause the video here so that you have some time to look at them and come up with your reasonings. Okay, so what'd you come up with? I can come up with a reason for all of them. So, accuracy is how close a measured value is to its actual or true value, whereas precision is how close the measured values are to each other. And sometimes people have problems with these two words because they can't tell the difference between them. And sometimes, even as adults, we use them interchangeably. So, let me see if I can show you the difference. And we could do that maybe with a dartboard. So, let's say that I'm going to throw 3 darts. I get a bullseye and a bullseye and a bullseye. Yay, that's actually what I wanted to get. And notice that I hit all in the same spot. So since I hit them all in the same spot, we would say that we were precise. But I wanted to get the bullseye, and that's exactly what I got. So I was accurate. Let's try it again. 3 more darts. Close, close, and close. Okay, I wouldn't say I'm precise because I did not hit the same spot every time, but I was accurate because I got the same number every single time and it was close to that bullseye. So if I got the mean, I'd get the same answer. Let's try again. A 9, a 9, and a 9. Okay, I did hit the same spot, so I'm precise, but I did not hit the bullseye. So I was far off, so I was not accurate. One more try. A 20, a 4, and a triple 10. I would say that I'm not precise because it's all over the board, but I also wasn't accurate because I didn't get a bullseye. Now let's say that you're going to measure both of these lines. Which one would be easier for you to measure and why? For which line do you think you would be more accurate? In other words, closer to the actual length. And how can you know if you are being accurate? What could you compare your answer to? How accurate were you if you tried to measure these? Think about these two things. What measuring tool you used, and also what units of measurement you would use. Let's explore these in the rest of this video. So what affects the degree of accuracy? Well, first of all, it's the tools that we used. So if we're using a ruler, you might notice that the end of your ruler doesn't start at 0. You can see here, it starts in a little bit, and it's about 0.8 of a centimeter from the edge. It's also difficult sometimes to measure. Like this isn't too bad, it's nice and straight, but this is curved, and my ruler is not flexible, so I can't actually get it on this line to measure it with accuracy. Also, it's the units we use. The rule of thumb is when you look at your measuring device, you're supposed to look at the smallest unit and then measure to within half of that. So let's look at our ruler again. In this one, you can see that they counted by centimeters, but there's actually the tick marks in between the centimeters. So the smallest unit is millimeters. So that therefore, when you're measuring this, the smallest unit you should use is half of a millimeter or 0.5 of a millimeter. Measuring errors. The length. Let's say you're trying to measure the height of this block. It would be really hard because this curved top. And we already talked about this curved line and how that's difficult to measure and be accurate. For a stopwatch or a timer, it's human error when you start and stop. So that reflex of when you start and stop, sometimes there's that there's a slight delay, or you might hit it prematurely. Mass is the scale calibrated correctly. So you can see right here it's at 0, 0, but you have to make sure it's 0, 0, and usually there's a little dial or something in the back so you can make sure that it's exactly at that. And for volume, reading correctly with the meniscus. For the meniscus, that's where this liquid here is curved, and that's what happens when you're measuring using this graduated cylinder. And you need to remember to measure the bottom of the meniscus. So this bottom right here is how you would read this correctly. So here's a way to remember the difference between accuracy and precision. The second letter in accurate is C, and C you can think of as correct. So in other words, like getting a bullseye every single time, we'd say that that's correct. Where precision, the second letter is R, and you can think of that as like repeating. Remember, I kept getting my 9. Okay, in this case, I don't even know what number that is, but I'm getting that same spot every time, and it's not the bullseye. So here's some key takeaways. Distinguish between accuracy, the closeness of the true value, and precision, the closeness of repeated measurements. So hopefully you now can distinguish between those two. Hopefully now you can recognize how tools, units, and techniques affect measurement and outcomes, that you can identify sources of error and think critically about the quality of the data, and that you can apply these concepts to improve your own measurement strategies. Understanding both accuracy and precision helps you become a more careful, confident, and competent problem solver. As always, thank you for watching. And if you like this video, you can leave a comment in the comments box. I'd be really honored if you followed me as well. But again, as always, thanks for watching.